Good morning, everyone. How is everyone doing? Can you hear me okay, everywhere? All right, very good. Well, it's a stormy day outside. I don't know about you. I like being indoors on this day, a day like this. In fact, I was flying from the Pacific Northwest yesterday, and I was watching the speed of the airplane when I was in between my little sleep modes, and at some point it actually hit something like 660 knots per hour. And when I did the kilometer calculation, that was something like 1,220 kilometers per hour. And that's pretty fast for airplanes to be going that speed. I thought I was just imagining something. But then I wake up this morning and I'm looking at the CNN news articles and it says transatlantic flights were flying at almost at speed of sound yesterday because of the jet streams and the windstorm that's going on. So it's good to be indoors on the 9th year of the hardwear.io Netherlands conference. Antrix, thank you for inviting me here. And when Antrix invited me to come and give a talk, I was thinking about what it would be an appropriate topic here. And as I looked through the agenda of this conference for the last 9 years, and then also look at, what's to come in the hardware research space, that's sort of cutting edge and things that we need to worry about, how can we not think about AI, right? That's the buzzword, from ChatGPT to the generative AI to, AI everywhere. It's just the thing that most engineers in the world are talking about. In fact, not just engineers, most people in the world are talking about today. So I thought that would be an appropriate topic to bring in here and specifically address this eclectic crowd of hardware researchers, right? The biggest gathering of hardware researchers in Europe. So why not talk about hacking with AI? So that's going to be my topic. And just to introduce myself, I am part of Intel. I've been there for about 25 years now. And these days, I lead the Intel's offensive security research team. So we've got a global team of security researchers, software, firmware, hardware, system-level researchers that are really breaking our own products before the bad guys do. That's our job. And I'm not a hacker myself, but supposedly I've been good at trying to find the best hackers in the world and bring them to a company like Intel and, make them have a lot of fun and do the best things that they do and, help the community, help the world with everything that Intel puts out as technology and making sure that our, breaking culture and making culture is pretty strong as an innovation company. So that's what I do at Intel. All right, let's get into our talk. First of all, how many of you believe that AI will make the job of defending cybersecurity worse? Can you raise your hands? Just a few. Interesting. All right. How many of you will think that it'll make it better? AI will make defending better. Also a few hands. So what do the rest of you think then? No effect of AI on security? Well, hopefully today we will talk a little bit about what things can happen both from a perils and from the promise standpoint. And you get to see, how do we recognize the presence of AI in our world, specifically in the hardware hacking world and hardware research world. So we'll go through some of the possibilities on both sides of the spectrum and then reflect on our own. Maybe we'll do a poll at the end of the talk and see if minds have been changed or if you're a fence sitter in this question that I just asked, you've decided to go one way or other. It's okay to go whichever direction you want. Nobody can predict where it's going to go, but it's just a hunch at the moment. All right, let's, one more question here. How many of you believe that AI-powered attacks are actually happening in the wild today? Wow, lots of hands are going up on that one. Okay, so are those good attacks or bad attacks? Are these ethical hackers or black hat hackers and, malicious intent folks are doing it? So I guess, given I asked the first two questions, very, very few hands were raised, but on this one we saw a lot of hands raised. Something to reflect on. Again, so I do believe that AI is already playing a significant role in cybersecurity. when it comes to engineering and inventing and finding new hacks and all. I believe it's already starting to happen. And it may not happen in the hardware hacking space as much, but it's certainly happening in the systems world overall. All right, let's look at some of the trends and forecasts here. So if you look at it, the news stories, right? Artificial intelligence is playing a bigger role in cybersecurity, but the bad guys may benefit the most. So this is arguing for bad things to happen with AI. You can look at it and say there's an arms race going on between security industry and cybersecurity, cybercrimes. The number of the dollar value, if you look at the AI and security cyber market, there is a prediction of about $133 billion by 2030 here. If you look at FBI, they're saying hackers are having a field day with open source AI programs. This is the ChatGPTs of the world and so on, right? People are having a lot of fun with it, hacking away with prompt engineering attacks and such. And then if you ask the different companies in the different industries, from utilities to insurance to automotive to retail and so on, a lot of people, the most consensus sort of opinion there is that they don't know how to be able to protect against the incoming attacks if they don't have AI to their aid. So they're looking at AI as the key method to be able to overcome some of the incoming cyber attacks of the future. So this is the trend in the industry today, but this is a pretty broad space, right? AI and security and the intersection of both of these things is a pretty broad space. Let's try to see how we can actually parse the various disciplines, sub-disciplines involved at the intersection of AI and security today. So first, I think we need to do some nomenclature level setting. There is the security for AI, which we'll talk a little bit more about, and then there is the AI for security, right? So what does security for AI mean? This means that every AI solution that we're going to be putting out there, whether it's for generative AI or models or, other sorts of capabilities that we put in the AI pipeline, how do we make sure that it is built with the right security, privacy, responsibility, ethics, all of that, bias, prevention, all of those things in mind? So that's what we're talking about here, bringing security principles to the AI solutions out there. That's security for AI. The other way around is AI for security. What are we talking about there? Well, you've got security technologies, you've got security capabilities in enterprises small and large, nation states small and large. You want to see how we can use AI to be able to deal with the security problems in that enterprise. How can we bring AI as an assist to deal with the security outcomes you're looking for? So it's going the other way around, where you're trying to bring AI to your conventional security-related problems and opportunities. So let's click down a little bit on that. So on the security for AI side, you're really talking about, things like the protection of the AI solutions. Oh, I have it twice there, don't I? There's something wrong with that there. Okay, so that's an error there. But if you look at the AI for security, really we're looking at AI being used as an aid for prevention, detection capabilities, and also for recovering capabilities. So all across, you're trying to bring the power of AI to it. Now, in both of these domains, you have the abuse of AI taking place, and that's what we're calling it as hacking the AI solutions themselves. And then there is the offensive use of AI, and that's where hacking with AI comes into play. So how do you use AI to be able to achieve your hacking outcomes, whatever the outcomes they may be that you're looking for? So that's what we're talking about as the hacking with AI. So if you go back to the title of our talk today, our focus is going to be on this subdomain, and this is where we're going to go deeper and deeper today and sort of look at the journey of the promise and perils around that. Are we good with the taxonomy that we're going to be using today? All right. So it's not to say that the other domain is not important. In fact, if you look at much of the security talks over the last few years, right, on AI and security, it's on the left-hand side. People have been talking about how to be able to go attack the ChatGPT solutions and the generative AI solutions. All sorts of stories that you hear about. There's a lot of things on the left-hand side. But I don't see a lot of people still publicly talking about in conferences about the right-hand side. And that's why I thought this audience is a perfect place to be able to have that conversation today. All right. So now we're going to sort of go into the dangers of using AI for security. So this is about AI attacks against security solutions and our capabilities. So the big question is AI going to empower the attackers to be as or more successful like never before? Right? So going back to the initial question that I asked, what do people think about it? Whoopsie. Let me just go back there. So if you ask that question, there was a CyberArk identity threat report. 93% of the surveyed people across the industry were thinking that AI-powered threats are a significant concern in their enterprise. Right? So people are really, really worried about the dangers of AI than the promise of AI among these people, these constituents. So let's look at what are the ways that you could actually bring AI to attack against security capabilities. Well, you don't need to go too far. The MITRE attack framework that's out there today that all of us know, right? You have to just simply look at it and say, if attacks are possible even before the presence of AI, and whether it's actually from a recon standpoint or from initial access or execution or discovery, how can all that be now enhanced? Faster, better, more effective. How can that all be done? And you have to look at it at the different levels of capabilities, attacker capabilities as well. What can individual groups do if they had the power of AI behind them to be able to go across this MITRE attack framework? What can organized criminal groups do in order to be able to carry out the MITRE attack framework-based, steps involved? And then what can the most powerful capabilities out there, like the nation-state attackers, do in this space? So if you look at the MITRE attack framework through the lens of AI, you will start to see that in every one of these situations, whether it's for recon or for execution or persistence and things like that, the power of AI produces a lot of new capabilities or enhances existing capabilities to the extent that we've never seen before. We're going to look at what that is in the next slide here. But essentially, the MITRE attack framework is still the baseline or the sort of the content you need to work with, and there's no more new taxonomy needed. It's really the MITRE attack framework, right? So look at some of the attacker advantages you would get with the power of AI. Well, first of all, the scale that you can achieve with AI across that attack framework vectors. You can get some unprecedented scale with the power of AI. You can see the examples on the right-hand side about how that scale can be achieved. The reach, right? You can reach into far more wider systems of the world and regions of the world using the power of AI. The stealth, right? Yes, stealth is very important. In fact, in the hardware hacking space, that's one of the reasons that we worry about this a lot, because there's not a lot of detection capabilities that are out there to begin with. And think about what would that look like with power, with AI being brought in to be able to increase that stealth capability in these attacks. Adaptiveness, right? So you can have self-generating code, you can have self-generating attack vectors that keep morphing before any sort of a detection capabilities are actually able to catch up with them. So the adaptiveness, the nimbleness of some of these attacks can become a bigger problem. And the persistence, no matter what you do, AI-powered attacks can increase our persistence capability as well, right? And last but not least, staying evasive. So no matter what you do to be able to have signatures and heuristics and other ways of actually coming at it, the power of AI brings a lot more evasiveness to the equation. So these are some of the attacker advantages. So this all means that you can now begin to accelerate some of the conventional attacks that are in the security space, in the hardware security space. We can also think about some of the new attacks that were not possible before the introduction of AI. So let's look at what they are in the next slide here. So accelerating conventional attacks. AI allows you to now find 0 days much more quickly, right? You don't need to actually worry about the fuzzing and other sorts of smart analysis capabilities. that take a lot more time, the power of AI allows you to go be able to find which of the vectors can lead to exploitable vulnerabilities, and then also be able to use the power of AI and the models and such to be able to find 0 days much more quickly. So we've already seen some of the data points in the industry now. The number of 0 days are actually starting to go up in certain industries. So the power of AI can allow us to be able to find them more quickly and more frequently as well. Automating reverse engineering at scale. So if you've got a particular attack vector or a particular solution out there, how to be able to sort of go back and look at some of the root cause of a behavior in a hardware system. You could use a lot of AI capabilities to do that automatic reverse engineering. And again, the manual techniques and the statistical-based techniques that we've used so far has allowed us to go certain distance and be able to get some success. But with the power of AI, you could go a lot further with the automated reverse engineering. Side channels, near and dear to the hardware security space, right? You could think about deep learning-based approaches to side channel analysis. Now you're looking at the ability to be able to discover side channels much more quickly and much more efficiently. And this has been demonstrated by the industry. If you look at some of the white papers that have been put out by like the ARM ecosystem today, it's already demonstrated that deep learning-based side channel analysis has sped up with the power of AI. And last but not the least, on the conventional side, realistic personas. How many of you feel like you've been successfully avoiding any sort of a phishing attacks that are coming toward you? Most of the time you're able to do that because when you look at those phishing attack emails and all, they make stupid mistakes. And they look fake for, a trained eye. Well, all of that capability that we have today as security-savvy people, that can even be defeated because the AI-powered solutions can actually produce realistic phishing attacks that even the trained eye could not really be discerning that. And not only in English or any particular language, once you have it in one language, you could use the AI techniques to be able to generate the same phishing attack in every language you want. And they all will look professional, coming from the agencies and authorities that you believe it's originating from, and you'll fall for it. So these sorts of social engineering attacks are going to become a lot more sophisticated with the power of AI. So these are some of the conventional attacks. Now let's look at the possibilities of new attacks. So daisy chaining and exploitation of malicious models. So dissimilar vulnerabilities that you could never in a conventional mode think about how to connect them together. Well, if you run AI analysis against those distinct and disjoint vulnerabilities, it'll start to find patterns in which you could actually mix A with Z, or something that is so distant and dissimilar vulnerabilities, you can put them together and achieve a certain exploitation. Right? This sort of a daisy chaining capability is going to become a lot more prevalent now. And of course, it's not just in hardware. Across the systems, you'll start to see some daisy chaining attacks. Supply chain attacks, things like Trojans in hardware IPs, and other sorts of sophisticated third-party and proprietary supply chain attacks. You can now think about a lot of the AI capabilities allowing you to put in smarts into these IPs that are going to be, absorbed by so many other, IP aggregators, right? People that use these IPs that are coming from trusted sources. Well, there's ways of now being able to, engineer in things like Trojans that previously was not done at the level that we're thinking about here. Model and data attacks, again, poisoning and other sorts of adversarial attacks against models that are used in critical decision-making and critical product development efforts and all, now can be compromised. And that leads to, sophisticated new attacks that was not possible. And last but not least, the concept of digital twins, which has been around quite a bit now. But now, when it comes to exploitability research, you can start to create a digital representation of your physical hardware and do a lot of scenario analysis of it. The what-if analysis of the digital, the different attack vectors. So even if you have a mitigation, well, we'll talk about this, but from an attack standpoint, if you have a vulnerability, what are the ways to exploit it? Well, you don't need to go and do the actual hardware-based tampering and adware-based analysis of it. You can create a digital representation of it and run the models all day long and be able to find all sorts of attack vectors in which that particular vulnerability could be exploited. Right, so the digital twin concept is going to be used by our adversaries quite a bit, not just the people that build the hardware technology, but adversaries as well. So, have I scared you enough? There is actually a lot of conventional attack prowess, and then also new attacks coming up. Right, so this is the sort of the perils, the dangers of AI getting in the wrong hands that we're looking at. Right, now let's turn our attention toward the other side, which is the promise of AI for the good guys. Right, so let's look at what that means. So, what's the most effective option to defend against AI? Anyone? That's right. That's also AI. Right? So, fight fire with fire. So, AI is also going to be the biggest advantage for the defenders. Let's look at how that's going to pan out for us, right? I'm going to show you some examples of all the places where AI could come to the rescue and come to the aid of the defenders to get the security right from the get-go. So first of all, on the security LLMs, right? So while we do have very generic large language models now that you can think about both proprietary and open source, you will start to see that there's potential for generating a lot of pre-trained and fine-tuned models that you could use for software development, right? That are security use cases, meant for security use cases. You can also use that for hardware analysis as well, right? You can start to think about all of the ways that front-end design and the back-end design can be done, and verification tasks can be done if you had a security-specific fine-tuned model that looks for the different vulnerabilities and be able to actually, guide the designers and the verifiers on how to do their job right. So the security LLMs are going to become a lot more prevalent, and we all should be paying attention to what those LLMs are that we could leverage in our daily work. In fact, there is so much of academia work that we've been tracking that I've put the links down there, but at the universities in New York University, NYU, at University of Florida, and many other places, there is a lot of work going on in being able to build out some of these security LLMs and demonstrate that it is possible to be able to go off and create these fine-tuned models that allows you to do this analysis with the power of AI. And you don't have to really go through the conventional techniques because it speeds things up and it's more effective here. Correct by construction. So why go through the effort of building a hardware and then later on thinking about did we get the security right or wrong, right? How can we build security right from the get-go into the architecture, into the design, and make sure that the correct by construction axioms and the aims can be achieved there, right? Generating high-fidelity specs, so natural language specs to actual code being generated with security considered in it. Right? It's not a theoretical idea anymore. There's been a lot of proof of concept demonstrations of being able to do this. Secure code generation right from the natural language specifications. Copilots, right? We hear about copilots in the software world, well, in the hardware space as well. In the next couple of years, you're going to be starting to see some copilots. In fact, just yesterday, I was reading a NVIDIA publication that was talking about how they've actually generated some copilot LLMs as well for hardware design, right? And it's not a surprise. We have to go down this direction because copilots is another powerful way of making sure that when somebody writes a Verilog code or RTL code, when the moment they actually try to write it in a way that introduces an insecure, function or insufficient or insecure behavior in the system, the copilot assists them and says, hey, you know what? If you do this, you're going to lead to, some sort of a, let's say, input validation issue or a access control issue and such, and it'll guide the designer to go in the right direction. So these kind of copilot capabilities are going to be very, very important. Just-in-time micro lessons on correctness of security implementations. So, we will get to the point where you could say, if it's not secure, you will not be allowed to commit the code. Imagine a world where designers would actually be doing things right from the get-go, where there's no concerns about security issues being passed down the road into the next stages of the implementation. It is possible with AI. Now, if we do end up introducing the vulnerability one way or other, can we use AI to be able to identify and surface those vulnerabilities, finding those real vulnerabilities using verification techniques and using LLMs? Again, you can see the academia papers that I'm referring to on the right-hand side. There's quite a bit of work already showing up that holds a lot of promise. AI-powered fuzzing, right? How can we take smart fuzzing techniques that are already good in things that they do, but bring the AI prowess to it so that it becomes even much more scalable and dealing with some of the hardest hardware fuzzing problems that are out there? So systematically performing adjacency analysis. So if you've got one particular vulnerability and you're worried, how many other similar instances exist in the rest of the hardware system that we're looking at, or other hardware systems that may have a similar capability? Well, you don't have to really go through and work hard at finding those adjacencies if you had the power of AI capability, right? You could be actually running this adjacency analysis with a lot more scale and a lot more capabilities. And then once you have mitigations for the different security vulnerabilities, finding the effectiveness of the mitigations that you're putting in place is going to be very critical, right? We don't want to be proven that just because we fixed a particular bug in a one way, now you ended up creating a can of worms and created all other issues in the system, new vulnerabilities being introduced. So you want to do that if-then analysis, right there with the mitigation effectiveness. Well, if you had a capability like a digital twin that I'm showing on the right-hand side, you could do the what-if analysis all day long and think about all the possible scenarios that particular change that you're making can protect against the security issue that you're worried about, or show another way of getting the same sort of a compromise happen, and therefore the mitigation is deemed as ineffective. You can do this sort of analysis upfront using AI. So the predictive analysis using digital twins is going to be a very, very powerful mechanism going forward. Let's look at one last area. Now let's say that everything that we talked about so far was in the process of designing and developing a hardware system. You could also think about the prowess of AI in the actual silicon design itself, or the hardware design. This is a conventional, European processor initiative system, right? So a very generic ARM processor-based SoC there, system on chip. And, one thing you could think about here is actually adding micro AI engines into every one of these IPs in which there is some level of data crunching or control-oriented security risks that may be introduced, or assets may be there. There might be a TPM, there might be a PCIe access or a memory access that's happening, and you want to make sure that there are no security-related threats that are being realized runtime, where you could introduce the concept of micro AI engines that allows you to be able to deal with these issues right when they're happening and catch them. And it's also not a theory. And this is the only place that I actually have, a mention of a technology from Intel. So it's not a vendor presentation, right? So we have an example called, it's an anomaly detector, right? Anomaly, the ABD technology in Intel's threat detection technology. What we done is we're actually looking at the memory accesses patterns. And we're using AI to be able to look at the memory access patterns. And when we realize that there is a memory access pattern that mimics a ransomware attack, or some other sort of a spurious attack patterns, we're able to signal that back to the operating system or to the Microsoft Defender capability that might be using it, sitting on top of it, and then be able to stop that attack right on its tracks. Right? Runtime-based capabilities. So if you think about these kind of checking capabilities that are strewn all across the system that are AI-based, then you could get to the point where even if there was a vulnerability when you built the system and it's in the design, the moment somebody is trying to exploit that, you might be able to catch it runtime and then be able to remediate it and save the customer's data and so on. So these are some of the possibilities and promises of AI that I'm very excited about. So, I'm going to go toward the end of our conversation here. What is my call to action? Well, it's the same call to action that I'm asking the researchers in my team as well. So I thought this audience would really, reflect on the same sort of steps that we can take as a community. Number one, do realize that AI is going to be an indispensable expertise that we all need to have, right? If you've only been admiring the lure of AI and haven't done anything with it so far, this is the time to actually get familiar with it. Start learning about how you can actually, be a user, a consumer, or a, inventor using AI, right? So AI is going to be at our, big aid as a security professional. I do believe that those security professionals that are AI savvy are going to be the most successful ones in the coming decade, right? Because the effectivity that they will have in the industry to be able to, whether defend when you're designing the product or defend the enterprise when you're using the product, if you don't have the AI capabilities at your disposal, you're going to be falling behind because the bad guys will definitely be using that. So the good guys need to be there on the forefront using AI. So continue to sharpen your conventional expertise. Of course, the next, Trojan detection technology or a side channel access technology, we need to be able to work on those conventional technologies, but then blend in the thought of AI, just like the way we've looked at some of the examples today. It is important to be able to actually, bring that AI prowess to everything that you're doing today. So what does AI acumen mean? Well, certainly the theory part of it, right? Understand the theory about how AI, where it works and where it does not. But then go beyond the theory and actually do some hands-on stuff. It's pretty easy these days to be able to pick up or have access to different models and different LLMs. And, some of the academic research examples that I showed, those are all open source and available. So get your hands dirty and start playing with these AI models and AI capabilities to be able to bring to, your own security research and security activities that you're working on. There is a thriving community that's coming together in applying AI to security, right? I expect that large and small conferences will start to have a track around applying AI to security going forward. So get involved in it as well. And, as I've shown in some of the examples, the applicability of AI is not just in one particular mode, in a very limited mode, right? You can do that in a white box mode. You can do that in a gray box mode. You can even do that in a black box mode to be able to find the different kinds of security problems that are out there with AI. So it doesn't mean that you have to have access to the code, to the design, to the specifications and all to be able to apply that. You can do that, from a black box standpoint. And if you're in a company that's actually responsible for building these products, and so you want to apply these techniques before the launch of the product, certainly you could do that. But you could also do that as a defender, somebody that uses this technology, and you're responsible for protecting it in field. You can still apply AI in that situation. So, in all of these situations, if you're a researcher from any of those 70-plus companies that Antrix talked about, think about how you would actually approach the opportunity with AI. It is a once-in-our-lifetime opportunity, guys. This is what I call the ultimate equalizers against the bad guys, right? Whether we do it or not, the bad guys are going to be using AI to be able to defeat our systems and security that's out there. So we need to be really getting ahead of them. So, summarizing together, how are we doing on time? Okay. So, security has been, is, and will always be a race. The bad guys will always have the last move with security, right? That doesn't get changed at all with AI. But like I said, malicious folks, malicious offenders are going to be using AI. And if they actually get to that and use that in a significant way before we get to it, for the short term, for the medium term, things are going to get significantly worse, right? Because they will be using that stealth and the access and the reach and everything that we talked about earlier to be able to get ahead of us. And we will feel like our profession is falling behind. But on the other side, if we start using AI right on, head on, and, we start using it pervasively in all different aspects of the ecosystem, then we will have the largest ever opportunity I think. If you think about the situations where you're doing correct by construction, you're doing runtime monitoring, you're doing, all sorts of analysis of known vulnerabilities and the mitigations and all of that stuff. If you did that all very well using these capabilities, what's going to be left for the bad guys to do? Right? So that's the prowess of AI. This is an ultimate equalizer, as we call it. Right? And so if we do that, then I think we can certainly get to a point where these dangers and not acting first and not acting, pervasively is something that should motivate us to go do something about it. And so the promises that we're reflecting on today are really, really tangible, long-term promises. And so we should really be able to take that and hopefully out of this discussion, think about, what have you done today to be able to take on, applying AI to your own security work today. So with that said, let me go back to the previous question that I asked. How many of you think that AI is going to be to the aid of the defenders in the industry, in the cybersecurity? I see a few more hands going up. Some minds have been changed out of the conversation. But I'd be happy to talk more about this. I know I didn't go into some of the details of every different points that I was making, but I'd be happy to take questions on it and discuss more and engage in debate. I don't have all the answers for it, but I do believe that this is an important conversation that we all should be having as a community. So with that, I'm going to start to wait for our questions here. And this is a little sonnet that I think is pretty cool that talks about how the defenders for AI for security should see themselves. And again, the author of this was a ChatGPT prompt that we asked about. So you can read through that. But questions now.
Thanks, Dhinesh. Let's give a warm round of applause. And let's also discuss this. Do we have questions from the audience?
Yeah.
Raise your hand, please.
Don't be shy.
Please don't. I have a question then.
Please.
So AI or machine learning is quite famous by our inability to explain the results, right? So you get the result from machine learning engine, and you would never be able to tell why exactly it's thought in this way.
Right.
How does it all play with things like trying to protect silicon, for example, or some other areas where explainability of the results is still important?
Yeah. No, absolutely. I think when it comes to adoption of AI, explainability is a very, very key vector, not just in the security space, but in general, the use of AI technologies without the explainability, it really creates a lot of situations. The hallucination to, made up realities and, how did the AI response come to a conclusion? We don't have a lot of visibility into that, and that can actually deter us from using the technology, right? So I think this is an active research area where we not only need to know what was sort of the rationale for something to be provided as a solution by the AI, so that the explanation should be coming with it. As users, we should be demanding that if we're expecting that service coming from a third party. And if we're building it on our own, we need to be thinking about what are the ways that we could actually have explainability built into the AI usages as well. And actually, solutions are being built. There is a scorecard system that is being developed today that actually deals with some of these explainability-related questions. And so if you get used to the point where every AI solution will also have a explainability scorecard that comes with it, and the scorecard would have all of the details about some of the rationale that's used by it, what are the model weights, what are the biases involved, what are some of the caveats involved in that model usage and the model execution, I think that will help to bring out transparency in the AI solutions out there. And then if there is any sort of deficiencies within it, we can look to correct it, because the transparency helps us to see where the weaknesses are and be able to resolve that. And I think that is going to be a key stumbling block and key roadblock in being able to adopt AI in real big product solutions. And if I look at, what would it take for Intel to be able to build the next chip using just AI, these kind of problems, we need to solve that first. Right? And so I wouldn't get to the point where we just run the AI and spit out a chip and then be able to go fabricate that. We're nowhere near that today. It is only an assist for the experts involved. So can we go faster with where we need to go with the power of AI, not necessarily replace what we do today conventionally? Yes.
Thanks for the answer. Do you have any other questions?
Yes.
Okay, we've got one.
So microphone coming, I think. A couple of them, please.
So thank you very much. You mentioned like micro architectures for AI that reside directly on the chip, so in hardware. Do you have like any numbers on how much hardware overhead that would mean in like resource consumption, die area?
Yeah. No, I think real estate in a hardware chip is always premium. Right, so we need to be really worried about how much of an extra real estate does an AI engine take. Well, our experience, at least in the first 2 generations of trying something like this, has been that it doesn't take a lot. What we call micro ML technologies that we can embed into the silicon, right? They are very, very minuscule real estate that it takes. A few circuitries, a few hundred, flip-flops and all is what we're talking about. And I believe that this is an area of innovation where it'll become much more efficient and much more effective going forward. So the overhead part of it is always a very key criterion for adding something like this as a smarts into that. Not only the overhead from actually adding that, extra circuitry, but also how much of an overhead does it actually introduce when the runtime, when the execution is happening, when the boot of the system is happening, and so on. We need to be thinking about the overhead in those situations as well. So so far the experiments that we've tried in Intel and what I've seen in the academia as proof of concepts and all does not feel like it's a big worry to be concerned about here. I think we could be really good with that, with the usefulness and efficacy that we get out of that. Sure. Any other questions?
Just following up on that last answer.
Yes,
so you said the micro ML is a few hundred flip-flops. Under what circumstances is that actually like sufficient to build like actual machine learning capability?
Yeah. So Zeno, thank you for that question. I think in these kind of situations, we're not talking about giant models being a part of that micro ML capability and all of that. You would have some sort of an offline analysis done about the kinds of parameters you need to check and have in place for the runtime detection. And the final analysis outcomes is what you're putting down in the circuitry, right? It's not the full model that actually runs to the back end to be able to do a lot of the inferencing and all of that. It's doing a micro level purpose-built service that's been already pre-trained, fine-tuned, and the responses that it provides is actually very specific, almost like a single purpose that it has. And that's why it's such a micro nature of it is going to be important. We may have multiple of them across the system, but each one of them would have a very small, dedicated purpose that's been optimized for the size and the performance that it needs to have.
Sure. So you gave the example previously of like memory access patterns, and you're basically saying the actual circuitry is just basically signatures of these are the memory access patterns that some other analysis has come up with as the suspicious component.
Exactly.
Okay.
That's right. Thank you. Any other questions? Yes.
So, what do you think of suitable inputs as training material for these co-pilots you mentioned? Because if you design silicon, somebody needs to tell the model that's trained what's secure and what's not.
Right.
So, would you just take academia work as an input, or what could you think of?
Yeah, no, that's an excellent question, and not just for security of it, but the quality of data that we use to train the models is basically garbage in, garbage out, right? So if you have bad models bad data that you're using to build these models, then you're just multiplying how much of reach that this sort of a bad model will have in the users community, right? So it is a question and a challenge that we need to deal with. My hope is that the data quality will continue to improve over time with human intervention as well. As we find, flaws in the data that was used in the model, we need to have some level of unlearning capabilities as well. Unlearning itself is a massive area of research at the moment, right? How do we get the model to actually unlearn something because it was incorrect, it was a bias, it was insecure, all sorts of things that for reasons for why we want to unlearn it. But I think unlearning is going to become a sub-discipline of its own, that it will become an automatic thing. When you find something that is not the desired outcome, you're able to go off and correct that. So the next time you run it, it's going to become, a more capable system that doesn't actually have that same flaw in it, that it propagates to the next level. But exactly how to do that as a science is still being worked on in academia and industry as well. Yes.
So we have time for one last question. Here, please.
Yes.
To build up on the previous, thank you. To build up on the previous question, those AI systems can be good at detecting. Still, they make mistakes. So once we detect a potential threat, how should the processor react? We are always a little bit afraid that if we just shut off the processor incorrectly, that will annoy everyone. What do you think there?
No, I think, so I hope everyone heard the question. So if you do detect some sort of an anomaly, what should the behavior of a processor be in those situations? Not resort to shutting it down every time it sees it, because it could also be a false positive, right? So I think, once again, I don't think it's perfect, the state of the art at the moment, but I look at it as once there is some sort of an anomaly detected, it's going to pass this information to a policy-based engine or something that is higher level in the system. And then that higher level policy engine would have modes that would be more aggressive for critical applications, less aggressive for, normal applications. Let's say that you're using it in the defense industry and you want to be able to deal with, even possibilities of small things going wrong. You can set that to an aggressive mode and then be able to sort of, bring the system to quarantine the system or do something that's an aggressive action. But in a system where, let's say, you and I are using it to just go to play video games, right? It could be a different, very benign environment, and you don't need to be in that aggressive mode. So exactly what we do for a given anomaly is something that I think, policy-based engines that sit on top of these detectors need to make a decision on. I don't think we want to get to the point where those individual engines themselves are shutting down the system, because there are so many other factors that play about the scenario in which it's happening and what the user wants to do in that situation as well. Okay. I think that was the time we had.
Yes,
but like I said, I am going to be around today, so please stop me and ask me any questions. I'd love to be able to engage in this conversation about AI and security. This is a passion of mine. Thank you very much.
Please give a last